Thanks for coming, guys. I work at AVC. We're a venture firm in town. We haven't done any geothermal investing yet. We'd like to. This panel's one of the reasons why. In the last few years, it's become possible to take an electron or a set of electrons, turn it into intelligence. That, along with broader trends of electrification in our transport and our homes and our industry, is causing a huge surge in net electricity demand. We really haven't seen anything like it in 40 years in the US. And we don't have, truthfully, like the generation, the transmission, the supply chains, or the talent base that's needed to support that new demand. So in theory, geothermal is a really great solution to that problem. It's clean, stable, abundant. There's an existing talent force, as Jamie said, in oil and gas. It's modular. It has kind of all the advantages, but so far really hasn't lived up to the promise. And I think this panel's central animating question of this panel is, what needs to happen to allow geothermal to scale fast enough to meet the demand from data centers in the next 5 to 10 years? With that in mind, I believe that earlier today, John, you released a new report on what would be needed for, like, the extent to which geothermal can actually meet this new growing demand. Can you tell us about that?
Sure, yeah. Hi, everybody. Rhodium put out a report today that looked at the potential for geothermal in the context of all this new electricity demand you were just talking about. And we found first of all, the first thing to know about the electric demand, it is uncertain. We don't know how much, we don't know exactly where the ceiling's going to be. But taking a pretty aggressive view of demand out into the 2030s and assuming that that demand scales where we already see a lot of data center activity, geothermal has the potential to meet about 2/3 of that demand if it can scale fast enough to meet the need. So that first of all was surprising to us. I think it's a reflection of a lot of what Jamie was talking about, that the technology is really getting into a new stage, that new capabilities and new cost and performance attributes that can really make it possible to meet the need here.
Can you put some numbers on that? Like, what is the growth in demand that you're expecting in that model? What cost does geothermal need to get to in order to reliably be able to scale? Like 2/3 is a lot of the overall demand. And as Jamie said, probably 3 orders of magnitude more than the amount of geothermal we have today.
Yeah, we're talking about a 2 to 7x growth in geothermal over a decade. So from where we are today. Okay. So that's big, but
global.
That's no U.S.
Okay.
That's big, but that's not insurmountable. I mean, that's totally. I mean, you can see a path there. And on top of that, we used basically some of the upper bound estimates from the Lawrence Berkeley lab and did a range of other analyses to take a look at what total demand would look like. And I mean, so we're in gigawatts. We're talking about 18 gigawatts of geothermal online by the early 2030s, which is again a lot, but a meaningful amount. And on cost, it's worth reminding. People are looking for speed and capability more than price when it comes to data center service right now. And so we taking into account some willingness to pay a premium for power fast, looking at ways to attach the geothermal behind the meter at the plant so that you don't have to deal with transmission and other costs, were important parts of this equation to make this happen.
Got it. And Drew, at Innerspace, you guys have released a kind of complementary report today, or complementary tool. Can you tell us about that?
Yeah. Ooh, that was loud. So I mean, I think it's a perfect complement to what Rhodium did, where they kind of put out what is the scale of the solution that geothermal can provide for data centers. And I think it's kind of staggering to think that 2/3 of the demand can be met by geothermal, because so many people right now are scratching their heads of going, how are we going to power this? And we now know, because of the Rhodium report, that we have the solution, the heat beneath our feet. And so what we tried to do at GeoMap, which is a tool that you can play around with over in that back corner, is to say, okay, well, Rhodium said we can meet 2/3 of that demand, but where can you meet that? Where are the best places in order to do geothermal data centers? And so what we did is, late last year, the International Energy Agency put out a report looking at the future of geothermal, and they tapped Project Innerspace to help out with that. And we developed a model to estimate what is the total heat beneath your feet at any given place on Earth at 5 kilometers, which is basically what most oil and gas wells go to now, and 8 kilometers. So we then took that and plugged it into the model, and then you can see on the map right now, we put that where are the fiber nodes globally. And so if you overlay those two pieces of information and say, where's the best heat? Where are the fiber nodes? Those are the hot spots, pun intended, of where you could actually do data centers. And so there's a lot of really interesting factoids that come out of that analysis that overlap with some of the findings that John and the Rhodium team found. One is that the western U.S. has a ton of potential. For anyone that knows about geothermal, that's not much of a surprise. But what's interesting about the West is there's a lot of federal land. And so there's potential for the U.S. government to play a really key role there. But there are some other surprising pieces that Texas, for example, is one of the best places to put a geothermal data center because it's got heat, it's got fiber, and it's got the workforce ready to go. And so I think we weren't super surprised by that, but I was surprised about how big Texas's potential was from that analysis. And then it kind of spreads over into the other parts of the Gulf Coast, which was very surprising to me because most people, when they're thinking about geothermal, they're really thinking about west of the Rockies, but the analysis shows us there's a lot of potential east as well, which is a game changer in terms of what the Rhodium report found is that, 15 of the 17 largest markets could be 100% geothermal, and so many of those markets are west or east of the Rockies, and our analysis back kind of complements each other and shows that is where you could do that, which is pretty cool.
That's awesome.
Or pretty hot.
I want to come back to this federal land question with Ishan, but I think it's worth really just putting pressure on this 2/3 number. Like, what are the characteristics of the 1/3 of data center demand which geothermal can't meet?
Yeah, I mean, so again, this is assuming you're scaling where there's already data center activity, right?
Okay.
So we actually found there's even more potential if you put all the data centers where the best
Where the
geothermal
heat
is.
is.
So that's just worth
But
keeping
there's
in
no
mind.
fiber necessarily.
Right. Yeah. And well, even if you solve for fiber, there's still a lot of potential. But it is this east of the Rockies, actually East Coast, Northeast area where Northern Virginia, where the scale of demand is just so big. First of all, and then the resource is there, but it's just not as plentiful, right? So it's like that's what that other 2/3 is, and I mean. That's still, there are other solutions to help meet that demand, but just the fact that we're finding more than half can be geothermal is important.
And Ishan, you worked on this in the Biden White House. What is the role of the federal government here? Both, in theory, what's the role of federal land? And two, what should this admin be doing today from a regulatory perspective, from a land perspective, to help geothermal move faster?
So Arthur, before getting to that, if I could just level set on some numbers. So back when I was in the government, we the scary part was that we actually just don't know how much demand is from AI, right? I think you heard this earlier today. It's 4.5% of total electricity demand, potential for compound annual growth of 7 to 12%. The number that we were working with was we need by 2050 700 to 900 additional gigawatts of what we would call base load power. What that means is it's not always sunny, it's not always windy. You can't power a reliable grid with solar and wind. So you need things like nuclear and geothermal to provide that resiliency for the grid. So 700 to 900 gigawatts of additional clean, firm, or baseload power we need by 2050.
That's like 500 Austins demand for power.
Yep.
Exactly. So I think last year, the U.S. saw the first nuclear plant to be completed, and it took several decades, right? It was billions of dollars over budget, and we built 2 gigawatts, right, out of all of that. And I think if we look at the trajectory of nuclear over the past from now into 2050, we see nuclear at best putting 200 gigawatts on the grid by 2050. So remember the number I said, 700 to 900 gigawatts of baseload power. Nuclear is only going to deliver 200. So my main question is, where is the remaining 500 to 700 gigawatts going to come from? The answer is geothermal. Now, this 700 to 900 gigawatt baseline was before we saw all of the latest developments of AI. So that number, right, if we think about AI, if you want to search your phone, you want to search on Amazon, for God's sakes, anytime and order things, you want to be able to do that 24/7. So the problem then pretty quickly becomes, how do we get that baseload power online as fast as possible? And this was something that we were really dealing with in the federal government, which was, as Drew mentioned, there's a ton of federal land that has a fantastic geothermal resource available, right? What for the past, I would say, 20 years, the problem, and Cindy has probably experienced this pretty frequently, the government hasn't been the best partner when it comes to deploying geothermal resource. You need permits. It's often really difficult to understand which agency has jurisdiction over the federal lands. So the idea of, in simple, let's deploy a bunch of geothermal on federal lands, in practice, is really freaking hard to do. In the last year and a half, 2 years under the Biden admin, we got rid of a lot of that regulatory thicket that's required to build on federal lands. In fact, one of the last things we did was pass an executive order, which is the only executive order, or one of the few, that has still survived the Trump admin, which basically leverages federal lands with the intent of competing with China on AI. The thesis being that, as we heard earlier today, power is one of the critical components of being able to compete and build data centers and be able to win the war on AI, or the race on AI. And so by using federal lands where there's a tremendous amount of resource, all of a sudden you can start building these baseload power projects in 3 to 4 years, or even less potentially. So there's a huge, to answer your question, Arthur, there's a huge role for the federal government in providing both early demand, and I think you'll hear later today, a lot of the federal government's military bases, and I think Cindy's experienced this firsthand too, are now beginning to buy geothermal projects because it provides a level of certainty. For example, it's less likely to get attacked by an EMP strike. It's underground. There's a lot of benefits to powering military bases that maybe I'll let Cindy elaborate on. But the premise is that the government has such an immense role to play, both in providing certainty as a customer, in helping locate geothermal projects on federal lands, and more generally in providing the patient capital required for these projects to scale. Because if we do this right, there's a real chance that we can close that 500 to 700 gigawatt gap through geothermal.
So you guys did a lot of this already, it sounds like. What's the policy recommendation today?
So I'm glad to hear you say this. So one of the timelines that this executive order that we had worked on suggested was, let's identify priority geothermal zones. This is a concept we sort of came up with, right? But it's based on this premise that builds on the rhodium analysis, which is that if you were to guide data center development on where's the really good geothermal resource, and then you were to use the power of the federal government to clear the regulatory thicket to develop that geothermal resource on federal lands, all of a sudden you can see significant cost declines. I think, correct me if I'm wrong, but it's 31 to 45% reductions in cost for powering these data centers than if you were to just go about data center tier 1, tier 2 data center markets. And so what you see is these priority geothermal zones, the Trump admin was supposed to designate them by March 15th. We'll see if they do that. But I think the real pressure is, let's take advantage and be smart about blending the opportunity for financing these things with the regulatory certainty that comes with federal lands and a partner in the federal government, and the fact that the geothermal industry is extremely hot right now, able to produce this electricity at, I think the analysis out of Nature in this year says by 2027 you can produce geothermal at $80 a megawatt hour, which is one of the cheapest forms. And so not only do you see a very fast form of electricity coming online, but it's also pretty cheap too.
And Arthur, could I just dig deeper real quick on that? So drill deeper. One of the central goals of the work that we're putting out in GeoMap is to be able to answer that question of where are the best resources to put geothermal projects, right? And so we now have that. That was kind of an abstract theoretical question of, well, where would we put it? I don't know. The West is good, but now we actually know. Like, we know that this square kilometer is better than that square kilometer, and we're able to bring in all of these different factors that are really important for where and how you would site a data center. And I do want to hear from Cindy here, because I think she's got some really interesting things. But let's make sure to circle back on the national security piece of this, because there's a really important part of this conversation that I think is worth having a bit more convo on.
I agree. I want to talk about the national security piece. I also want to talk, John, about the implications of modeling and what that allows financiers and other stakeholders to do. But Cindy, I actually think what I'd really love to hear is, what is it about geothermal specifically that makes it good for data centers? Like, what are the qualities, other than that it's reliable, that make geothermal appropriate for a data center especially?
Yeah, I've been sitting here for 15 minutes listening to you guys, so there's so many things. First, before I answer that, I wanted to tail onto what John was saying. So we did an analysis. You said 18 gigawatts by 2030. We did an analysis of can we deliver 5 gigawatts by 2030 for one of the hyperscalers. And so we took a look at the lower 48, and conservatively, there's up to 7 terawatts of geothermal resources, and that's conservative. That's removing national parks. That's removing slopes greater than 20% because you don't want to drill on the side of a mountain. And so then we said, okay, operationally, can we do it? So we said 500 wells per year for 5 years is what we would have to drill. And that leverages, to Jamie's point earlier, that leverages less than 5% of the oil and gas industry. So the answer is yes, we can deliver 5 gigawatts by 2030 as a single geothermal company. So the 18 gigawatts, I think, makes complete sense. So, yeah,
That's
Arthur,
epic.
getting back to your question, why geothermal? We do actually geothermal, and we also do energy storage deep in the earth. Energy storage is very much like pump storage hydropower, but instead of pumping a lake up a mountain, we're putting it deep in the earth. And there is a geothermal benefit that improves your round-trip efficiency. So we, with geothermal power or pairing our storage with solar or wind, we can provide base load power to data centers, because data centers need dispatchable power. They need it 24 hours a day, as you were saying before. And I think we need all of the power sources together, but that's one of the unique things about geothermal is it's 24/7.
Can you use the heat, the fact that it's a thermal resource, to help with cooling, or other ways of juicing joules out of the same system?
Yeah, I think Jamie said it beautifully. There's a temperature in the earth that's constant, 55 degrees F, and so yeah, the cooling needs for data centers are huge. It's a huge power demand. And so by leveraging that temperature, that constant temperature, yes, I think that can definitely help. And there is also one of the members of our team, Levering, who's our Russian rocket scientist. He's looking at how do you leverage the heat also just to create more efficient cooling, so even deeper heat.
I think it's something like 40% of data centers' energy consumption comes from cooling. And I want to foot stomp something that Cindy said, which is, Sage Geosystems has figured out this really innovative approach to storage that uses the subsurface in order to pair with solar and wind. Meaning that if we think about speed as really essential for baseload power, all of a sudden you can build solar plants pretty quickly. If you combine that with the capabilities of storage, pretty soon you have one of the fastest forms of baseload power available ever. So kudos to you all, Cindy and Sage.
Drew, it's clear that there is a huge possibility here. I think something like $7 billion have been put into fusion companies, probably an order of magnitude of that into fission companies. There's a Wall Street Journal article about one or the other every day.
Yeah.
Why is geothermal so unsexy, and what can we do?
Well, we're bringing the sexy back, Arthur. That's what we're doing right here, right now. Clearly. No, I mean, it's a funny question. John and I were talking about that last night. And why would you reactivate a nuclear power plant which costs billions of dollars and you have to retrain a whole new workforce versus saying, hey, wait, we could do some geothermal there, and well, not at 3 Mile Island, but we could do some geothermal in other places and have the same impact for probably a fraction of the cost. And I think it really boils down to it, and Cindy, you would know this better than I, but I think when most people who haven't had the privilege of coming to a geothermal house, when they think of geothermal, they think of Iceland, they think of maybe parts of California, and they go, okay, well, yeah, I don't live there. Next, what else you got? But the subsurface of the Earth, it's hot everywhere. And we have the technologies to tap into that heat now that we didn't have before because of the shale boom. And so we don't have to kind of invent a whole new suite of technologies to tap into this. It's here now, and I think people are just now waking up to that fact. And I think that's why you have both President Biden and President Trump saying, hey, this is something that we should be thinking more about, because going back to that national security point I was making earlier, no other country in the world is better at putting holes in the ground and bringing things out of those holes than United States of America. That is part of our superpower of how we developed as a country. It's because of that. And unlike in some other types of technology, nuclear, solar, wind, like China has lapped us. And we are currently winning that race on geothermal. And it requires investment in American ingenuity to continue to win. And I think there's a huge value in being able to have something where the United States can maintain a leadership position when it comes to energy and when it comes to ensuring that there is a supply of energy for data centers, which is a clear and pressing national security concern right now.
Yes, Cindy, where is oil and gas in all this? Like, why is it not for Halliburton execs up here or whatever?
Well, there's a lot of companies already pivoting in oil and gas. Service companies recognize that they can use their existing equipment, their existing skill set, their people and everything. I would say like one of our investors is Expand Energy, used to be Chesapeake, so kind of a mid-size oil and gas company. So I think the oil industry is definitely looking at geothermal, and to the earlier point, it's ready to pivot. It can build geothermal now. It can scale geothermal now. And I think that's exactly what you're seeing with next generation geothermal, is leveraging all of those capabilities.
To what extent would you say we're at the top of of geothermal's learning curve, and we've got a long way to go in terms of costs and bringing that down? Or are we already at the bottom of oil and gas's learning curve, and there's actually not that much more to learn because the shale industry's already done it for the last 10 years?
So if you're looking at the drilling technologies, it's there. We can, as a industry, geothermal can scale drilling wells, and we can leverage the cost efficiencies of the oil and gas industry. As the technology to harvest the heat out of the earth, so those thermodynamics, and then when you get the heat to surface, converting it to electricity. What I get excited about is I really do think we're on the low end of that learning curve, and we are where wind and solar were 15 years ago. That is why these $80 per megawatt or lower is going to be possible. It's going to be possible at scale, because that's where we are on the learning curve. And to the earlier point, I do think it's the American know-how and innovativeness that's going to help us bring the geothermal cost to those points.
Like, what specifically do we need to get better at when it comes to extracting heat from these systems?
You need to understand how the rock behaves, so that's kind of the geomechanics, and you need to understand there is a thermal depletion when you're harvesting the heat. Now, it will replenish, unlike oil and gas. Oil and gas doesn't replenish. So you have to understand the mechanics of the rock, the thermodynamics, and then how to design that well and build that system. And then when you get to the heat to the surface, current power plant efficiencies for converting heat to electricity are 8 to 12%, which is pretty low. There's other technologies out there. In fact, we're working on a CO2 technology that will improve that efficiency of converting heat to electricity to 15 to 20%. So that may still sound low, but that's almost double what the current. So it's all of those technologies together that are going to bring the cost down, the efficiencies up, and that is what, Jamie talked about the shale revolution. We talked about the shale revolution on the stage. That's what's going to bring us to the point where it's going to be cost competitive. If not, you may not even believe that there's a climate crisis. I think geothermal is still going to be one of the cheapest forms of power, and it's everywhere under our feet.
Just help me understand, like, let's say a well, you get, let's say it's $150 a megawatt hour out of a geothermal well. What would the breakdown of that cost be between the drilling, between the surface, etc.? Like, how do I actually think about the costs there?
Yeah, it's when we're looking at the cost breakdown, it's 35 to 40% well cost, and then it's probably 60 to 65% power plant or surface cost.
So if we get better at the power plant where you think there is a lot of room to run, that will be a big driver of those cost reductions.
Absolutely, but to be honest with you, it has to be a full system approach. We need to drive down the cost of the well, We need to drive down the cost of the power plant. We need to do it in parallel so that you're not driving down the cost of one while you're increasing the cost in the other. And so, again, that's something the oil and gas industry has done for the last 50 years. And so that know-how is already there.
So, yeah, go for it.
If I could just jump in, the other way to think about cost is just in terms of output per well. So I think folks heard Jamie say earlier today, the deeper you go, the more energy you get. I think one of the roles for the government has been supporting, so I don't know if anyone has had a chance to check out the PDC drill bits back there, but government R&D in the geothermal industry has been essential for the past several decades, whether it was helping spawn hydraulic fracturing, which enabled the shale boom, or is creating those PDC drill bits back there that you should definitely check out, which enabled our ability to horizontally frack and create enhanced geothermal systems. But I think the next frontier is what Jamie had mentioned earlier, super hot rock. So if you can drill, increase the temperature, drill deeper, if you can design wells that can survive the pressure, and you can design drill bits and equipment that can survive the temperature and pressure that deep, you can 7 to 10x the amount of power per well. And all of a sudden, regardless of how expensive it is to drill currently, a 7 to 10x increase in the power becomes far more economical, far more exciting from a cost reduction perspective in terms of dollars per megawatt.
As we go deeper, what happens to the power output? Is that linear? Is it exponential?
So it depends on the exact approach, and I would ask other panelists to jump in because I'm certainly not a drilling expert. But I imagine certain approaches are, let's say you can vertically frack, which I think is similar to the way Sage designs its systems. It's sort of a downward-oriented fracture. If I don't think y'all are doing this currently, but presumably, right, if you were to access a heat network that way, it's a different profile than if you pursue what Fervo is doing, which is horizontally fracking and hitting it deeper and deeper each time. I think the temperature gradient is pretty linear, I would assume. And I believe it's about 274 degrees Celsius plus is the exact temperature at which you would differentiate super hot rock, and you would start to see significant increases. But I don't know the exact.
I'm going to check with Cindy.
The power output is actually exponential to what we were talking about. If you've got, say, a 2-well system at 200 degrees C, which is about 400 F, you'd get 5 to 7 megawatts. If you're at 300 degrees C, you're looking at 30 megawatts per 2-well pair.
Is that because of the conversion cycle being more efficient, or what's the right way of why is that
Well,
true?
I don't think in equations, but my partners do. So you think about the enthalpy equation, it's the heat component of it. It's just more heat, more energy.
But I think it's important here, while that super hot rock could be a really big deal, it's like the fusion of
speculative things.
right. But we have today geothermal projects that are up and running that are providing that heat, and we have examples of falling down in a good way on the cost curve when they brought in an oil and gas crew to drill a well out in Nevada or Utah, as opposed to a traditional hydrothermal well crew. They were able to save 70% of the cost just because they were able to leverage that oil and gas know-how. And so we're going to be continuing that innovation and continuing to go down that cost curve, which is what unlocks the sorts of next steps that Cindy was talking about that we don't even need the hot rock for. If we get there in the future, great, it becomes that much better. But that's almost science fiction, whereas what we're talking about now is happening and can happen even more.
With like heating and cooling even more accessible, able to help directly plug in on data centers.
John, will you help me think from the perspective of Google? I want to build a data center. Let's say it's 500 megawatt data center, so like pretty big, not huge. What do I need in order to get confident in the geothermal, the output? Like, why would I not just hedge my bets, go with natural gas? We know it works. What would I need from a modeling perspective, from a certainty and a cost perspective, to actually pull the trigger on doing one of these data centers with geothermal?
So I think the thing to think about here, I mean, just you picked Google, but this really is any application, right? Like the geothermal technology we're talking about is like right at the cusp of what the finance sector calls bankability, right? Like it's like, okay, we know what we get when we finance this thing, right? That's basically the same question Google's asking. We know what we're going to get.
Google
right?
or their bankers.
Yeah. And a lot of this is experience, and a lot of this is trying new things. And actually, Google is working with a geothermal company on a data center in Nevada now to get that experience, right? But it's being able to now. First of all, Google's kind of unique because they have a very ambitious 24/7 clean power procurement goal, which steers the company to these. Riskier is not the right word, but places for seeking new experience, right? And figuring out how to broaden their solution set beyond wind and solar, and so there's a reason why they're leading in this space. But I think also helping these companies get to scale, get the access to firm power contracts. It's a two-way street. The company needs to know that when they build the thing, they're going to get what they need to pay off and provide the services. And meanwhile, Google needs to know that they're going to get what they want at the end of this process. And I think that's happening now with a lot of different experiments and projects. And one thing on cost I wanted to mention too is what Cindy described as the system approach with all these different components of cost savings. That is exactly how solar got cheap. It's exactly how batteries got cheap. It's exactly how EVs got cheap. It's not one
how shale got
innovation.
Cheap.
It's not one innovation. It's a lot of little things across the entire system that add up to dramatically cheaper delivered costs. And we're still seeing that happen in those other technology areas. And I think it's really exciting to see so many opportunities in this space right now.
It feels like there are all these different stakeholders. There's the financiers, there's the off-takers, the technology, the startups, the big oil and gas majors. My sense of this industry historically is that one of the challenges has been when any one person tries to get too far ahead of all the others, they end up getting burned. And what's interesting now is it feels like all the different stakeholders are beginning to move forward in lockstep. This is a kind of question to everyone, which is where are the big bottlenecks now? What needs to be unlocked? Is it regulation, or is it we need to train more Wells Fargo bankers how to underwrite these things? What's the right way of thinking about where the biggest problem is? Or, do we need the technology to mature for another couple of years?
Yeah, the two things that we think about are grid interconnection, and in Texas, the grid interconnection is actually fast, but it's still about a year and a half. And then supply chain on the power plant side. You've got some really good suppliers, Turboden or Ormat, but they're used to building these turbines and these systems, 2 or 3 a year. And as we grow as an industry, we're going to need 10 times that, if not more.
And I think that's a really interesting lever to be pulling in the policy context.
Supply chains.
Supply
Yes.
chains. Why are those turbines not manufactured in the United States? And again, in this really strange political moment where we are in, there is vehement bipartisan support that we need to be onshoring manufacturing jobs. And so why not onshore some of the turbine manufacturing in the United States? It has national security implications, benefits. It has economic benefits in that you have the ability to really scale up on those turbines, and it allows us to move much more quickly than we would be able to otherwise.
Do you feel like once you've proven your first well, and it's really working, you can just put in an order for 100 because you know that you're going to have the demand for 100? So is it part of this the first of a kind problem where you need that point of validation?
It's not that simple because what you need in the power plant, you need to understand your resource temperature, and you also need to understand your ambient temperature. So
it's quite precise to the site.
Yeah, I mean, you're going to design it for a range, but but if you're in an area, yes, it becomes very cookie cutter. But if you're moving from, say, Texas to New Mexico or to Utah, then it's not as cookie cutter because the ambient temperature changes as well as the resource temperature could change.
I went and saw the new supercritical CO2 turbine that they're working on at Sage a few weeks ago. It's 3D printed. Does that help? Does that mean you can more rapidly make for the specific set of requirements or parameters or whatever that you need for any given site?
Well, and that's what our supercritical CO2 technology is going to do. It's going to add to the supply chain because it's not organic Rankine cycle. Does the 3D printing help? The 3D printing actually enables supercritical CO2 technology to even exist because as you saw, the turbine wheel is like 7 inches in diameter, and you can't manufacture that with a machine. So it's 3D printed. So, and then all of the equipment is smaller because CO2 is very dense. It's a very dense fluid, so all the equipment just gets downsized. So to your point, Arthur, I think manufacturing this is going to be faster. It's going to be cheaper because everything's smaller. And it's going to help the supply chain just because it's going to make it, there's going to be competition for ORC.
I'm curious about, so there are maybe a couple of dozen geothermal startups and companies that are working on it. To what extent, and one of the things I hear a lot is like, our big differentiation is that we're just experts. We did this in the oil and gas industry. This is like a skill set that we have. To what extent is there particular technology innovations or technologies that are differentiating these different companies versus is it really like, okay, I'm in New Mexico, I know about this land, I know what it's going to take to get something drilled cheaply and at scale here. Like how do those two factors balance?
I think 80% of what we're doing, maybe 90% of what we're doing is off the shelf, and it's oil and gas, it's petrochemical, high pressure processes at surface. But it's still understanding, so instead of drilling, we're drilling deep in the earth, but instead of for hydrocarbons, it's for heat or it's for the Earth's pressure. So it's still understanding how to best leverage that. So how best to get the heat out of the earth, and then once you get the heat to the surface, how best to, again, convert it to electricity the most efficiently. So there's still technology improvements that need to be made. I think we're past R&D. I think it's more now optimizing engineering and driving the cost down toward that $80 per megawatt price range.
Sorry, Cindy, please finish. Were you finished?
Yeah,
Sure?
please.
Okay. Sorry, I didn't mean to cut you off. No, that's. I was going to say, I mean, one of the coolest parts of the job I used to have was I got to travel the country and talk to different communities and understand what are their power needs and how often power is essential to their economic development future. And almost everyone I spoke with was like, hell yeah, we love geothermal. Who's going to come build it? It's a huge problem of supply, right? And I think you heard part one of the problem, which is imagine having to 3D print your own turbines just in order to compete as a startup, right? Not everyone is as well capitalized as Sage or Fervo. So if we're thinking about how do we, and this is often the question I would get, is how do we create more Sages and Fervos? I mean, we need to help build the supply chain. It can't just be up to those two companies to build and bolster the entire supply chain. Imagine having a technology in this country that we are positioned to change not only the future of our own energy landscape, but the world's energy landscape. Because if we prove this technology out here, right, it's pretty easy to start drilling around the world. And in theory, the Trump administration should want American geothermal companies to be the ones drilling across the world. But it's not even a matter of, I think, just opportunity and America first. It's truly a matter of we don't know if we'll have enough energy to power our grids going forward. So this is truly a matter of national security in the context of leveraging every tool the government has and bringing forward a supply chain here and using our federal lands to have a sort of basic demonstrated or clear path to deployment so that it's not just Cindy and Tim at Fervo that are moving the field forward every day, but it's anyone in their backyard, someone who is a petroleum engineer today. Like I think many folks who I know that have started geothermal companies have the opportunity to switch from oil and gas into the industry. We haven't made it easy for them right now, and it's taken pioneers like the ones on this stage. But I think the macro opportunity for the government is really making it easier, and one of the best ways is solving the supply chain, is making it easier to interconnect. I think right now there's about a dozen or less gigawatts waiting interconnection from geothermal. There's legislation right now that's been introduced that makes it easier to prioritize baseload. And then the last problem I just want to table, and I think it was touching on what folks had mentioned, which is it took solar 17 years to really demonstrate bankability, right? The sort of certainty that you're going to get what you pay for. The problem we're facing right now is we need more shots on goal across the country. We need not just deployments in one basin or in one part of the country, but we need demonstrated track records that you're going to get what you pay for in more parts of the country. And creating a pathway for entrepreneurs to pursue this is essential, but more importantly, providing sort of that patient financing from the government I mean, that has never been more essential than today. And it's why we have the tools available. It's just we really need to use them from the government.
So what specifically would be like, and this is a general question, like what specifically are the most effective ways of financing geothermal? Both financing the companies and financing the projects themselves. You imagining like a loan program guarantee or like a loan program office guarantee or?
So I think one of the annoying parts of the way the loan programs office gives grants is it requires every company to pass what's called the National Environmental Protection Act permitting regulation before they can receive a loan. And so
isn't that mostly gone now?
Well, unfortunately, it's not. It's still by statute. So in theory, a court would still uphold it. But today, who knows? But I would say that there's a few adjustments, and I think Drew Interspace put out a paper recently, or there's some policy developments in the background that a few slight tweaks of, hey, if you can give the early access financing without requiring you to wait a year or 2 years for permitting, or hey, if you can confirm the resource by without having to sort of pass these permitting stages. I think there's like tweaks that you can do that make it more attractive to get to yes and get to certainty from a financer's perspective. But I've never put a capital stack together, so I don't want to pretend to.
John, what's the role of modeling here, and more broadly, like how does a financier think about one of these projects?
Sure. Well, I mean, I think one thing is certainty in the policy and market environment, and that is not what we're seeing lately. And importantly, I mean, there are tax credits for clean power that may disappear as part of the reconciliation package. And I think the fact that they are currently on the books and available for the long run is really important for these types of companies and projects, because they need to know that they can get that credit in the 2030s, right, to get to scale. So that would be a shot in the foot if you took away that. The other thing, the thing we think about is like, all these innovations we're talking about here today are not common knowledge in the market, in the finance sectors. And so, I mean, we revamped our entire energy modeling platform to reflect these new technologies just this year, and are seeing very different outcomes in our analysis now, and that's really exciting and important. And then socializing that, making it normal. I mean, we're playing catch up with the technology, and we've done the same thing with solar, and like we need to be. I mean, this is a great problem to have. This is super exciting, actually. But like getting more and more people to see what we're seeing in cost and performance and stuff is going to be a big part of what we're doing over the next few years.
Yeah, what are the lessons learned from solar there? Like, who were the first movers in terms of people putting really big dollars behind solar?
I mean, solar's a little different because it could start off distributed, right? So like a lot of it was you put it on your rooftop, and
let me re-ask the question. What are the big lessons from shale? And are there like examples of initial uncertainty that then like big financial partners moved into the industry? Are there people we should be looking at specifically?
I mean, the proliferation of startups, or that maybe they were wildcatters really at that time, was important because people just showed they could do it, right? And then now it's totally normal for Exxon to buy XTO or fill in and that's the sign when you've really made it. But I think competition among innovators is really important.
Well, and the flood of financing that came into the shale boom is one of the things that really helped unlock it, right? You had the George Mitchells of the world who figured out how to do it, and then you had the next stage of companies that have figured out how to do it more efficiently and cost effectively, and then you had Wall Street go, oh, that's interesting, and that's where we need to be getting to on geothermal. And just I think the shale analogy here is really, really informative. You look at all the geopolitical implications of the shale boom. The U.S. went from a net importer of natural gas to a net exporter, and everything that had allowed us to do. And we're on the cusp of doing that globally with geothermal and with power and with heat. And so if we can just figure out a way to capitalize and move some of this financing forward quickly, the geopolitical implications are enormous. Every country has the ability to be energy independent. Sorry, that's a big difference, and that changes things really dramatically, and that's what we're trying to do, and that's really exciting.
Ishan, Drew, John, Cindy, thank you so much.